Tomato is one of the most popular and widely grown vegetable crops in the world. Tomato leaf curl virus disease and its whitefly vector, Bemisia tabaci, are the most serious constraints to tomato production in Karnataka and also in most other tomato growing regions of India. Crop losses experienced by resource-poor farmers from this problem frequently reached 100%, affecting their food security, nutrition, and income. A breakthrough technology has been developed to combat this serious problem. 3 semi-determinate, open-pollinated, leaf curl virus-resistant tomato varieties, namely Sankranti, Nandi, and Vaibhav, were developed through farmer participatory breeding program by the University of Agricultural Sciences, Bangalore, in collaboration with Natural Resources Institute, United Kingdom, and the Asian Vegetable Research and Development Center, Taiwan. The project was funded by the Department for International Development of the UK.
Tomato leaf curl virus disease and its whitefly vector are the 2 most serious constraints in tomato production in Karnataka and also in different parts of India.
I think one of the main reasons why this project has been successful is the long period of funding that we've had, which has lasted over about 10 years.
We also surveyed tomato farmers right at the start of the project to find out what solutions they would be willing to adopt for dealing with Malle Roga, which is the local name for tomato leaf curl virus disease.
These 3 tomato varieties represent a significant achievement in tackling this problem because they are high yielding and highly resistant to virus, as well as possessing tolerance to bacterial wilt and high temperatures. These varieties have been thoroughly tested and they perform extremely well, even under the intense inoculum pressure caused by the arrival of the B biotype of Bemisia tabaci in Kolar district of South India. Official notification of variety names was published in the Gazette of India with the accompanying statement that they can be used throughout India for the purpose of agriculture. Breeder seed of the varieties has been purchased by 16 commercial seed companies who are currently using it in their breeding programs to produce virus-resistant tomato hybrids. Seeds of the virus-resistant varieties are being sold through different university outlets. Farmers have also multiplied the seed and sold to other farmers in different districts of Karnataka and Andhra Pradesh.
The university also formed a revolving fund for continuous supply of quality seeds of these tomato varieties.
AVRDC has already distributed seeds of these 3 varieties to 26 public or private institutes in 13 countries.
Resistance is really the cornerstone for any control of Gemini virus in tomato because resistance is cheap, especially if you compare it to pesticides, and it's built into the seed.
By growing leaf curl virus resistant varieties, farmers obtained 7 times higher profit than by growing susceptible varieties. A recent survey showed that the increased income from growing virus-resistant tomatoes significantly improved the livelihoods of farmers' families, and the extra income was spent on an improved diet, children's education, and health. The widespread adoption of virus-resistant tomatoes will ensure that tomatoes can be grown successfully even at the peak of leaf curl virus epidemic season. International collaboration is needed to solve these complex problems to get healthy crop.
We organized this field day with a very special purpose, and really we had 2 major purposes in mind. One was to demonstrate and show some of the technologies available for the control of tomato yellow leaf curl virus in India.
It's a good example for public-private partnership. I think what the companies like us would like to do is to put it into the right background for the farmers to use.
Part of this field day today, as well as exhibiting the tomato hybrids, tomato leaf curl resistant varieties, are the IPM technologies that have been developed to reduce pesticide use and to protect the young crop from the insect vector Bemisia tabaci. An additional benefit for using these IPM technologies is that we can grow the tomato crop with a greatly reduced amount of pesticide and insecticide. This then allows us to make value-added products which can be produced almost pesticide-free.
The impact created by these technologies is increasing, and if we simply compare the increased profits of tomato growers with the cost of the research, the benefit to cost return is already at least 764 to 1.
This is an important example of public-private partnership. The public sector has been doing a marvelous job. Basically, the fruits of research, which is the core activity of the public sector, must reach the grower and the consumer. On behalf of Namdhari Seeds, I extend all the support required for any future projects which will be definitely done to your taste and to your quality.